Hey, this is Mr. Aiden. This is Pre-Calculus Honors. We're section 3.4, solving exponential and logarithmic equations. This is where the fun begins. And so here we go. The algebra of logarithmic equations. We have we first want to take a look at how do we do the algebra to solve any of these equations. So just like think about adding. Well, what do we do if we're adding something? To do the algebra, we subtract. If we're multiplying, we're going to divide. If we square something, the opposite is square rooting. So what happens if we have logarithms? So here we have log base b of x is equal to y. So how do we get, if we want to solve and make this x all by himself, how do we get this x all by himself is we got to get this log base b out of there. And the opposite of log base b is b to the base to the. And so x is going to be equal to the base to the y power, and that would solve for x. We've done this before when we took a look at changing our logarithmic equations into exponentials. Okay, so if we take a look here, we have log base 2 of x is equal to 4. So how do we get this log base 2 out? We're going to do 2 to the both sides. What do we know 2 to the log base 2 does is it cancels out. So we have x is equal to 2 to the 4th power. And 2 to the 4th power obviously is equal to 16. So if you did this log base 2 of 16 in your calculator, you did the change of base formula or you just did a regular, you would get it equal to 4. So that gives us the so what is the algebra of log base b? Is b to the base to the, okay, both sides. Well, how do we get b to the x power is equal to y out of there? Well, we have to do log base b to both sides, log base b to both sides. And so here we have 2 to the x is equal to 5, okay? And so we're going to do log base b of, log base 2, because it's base 2, of 2 to the x is equal to log base 2 of 5. What happens with log base 2 of 2? It cancels out. It gets x all by himself. So x is equal to log base 2 of 5. And so log base 2 of 5 is going to be equal to something like 2.3219, blah, blah, blah. And if you did 2 to that power, you would end up getting 5. You could check your work. So what do we want to do for if we have an exponential? We're going to do log base of that b to both sides. Now what happens if we have a natural log? Natural log of x is equal to y. We're getting x all by himself. What's the opposite of natural log? Is e to the. And so that gets x all by himself. So if we have natural log of x is equal to 4, we're going to do e to the both sides. The e to the natural log of x cancels out. We have x is equal to e to the 4th power. And if you do that in your calculator, you have e to the 4th power is equal to 54.598, so on and so forth. Okay, and if you check your answer, if you do natural log of that to check your answer, you'll get 4. Okay, well, what's the algebra behind e to the x power is equal to y? Is we want to do natural log both sides, and that, so here we have natural log of e to the x equals natural log of 5. That cancels out the e, and we have natural log of 5, which is 1.6094, so on and so forth. Okay, so the algebra behind each one of these things is, what do we do if we have log base b? We do b to the both sides. We have b to the, we do log base b. If we have natural log, we do e. If we do e, we do natural log, and that is the algebra behind each of these functions. Now, let's go through a few examples. So here we're going to solve an exponential equation. So if e to the x is equal to 72, how do we get e out of there? We have to do natural log to both sides. So we have natural log of e to the x equals natural log of 72, not 75, 72. And so natural log of e, that cancels out, so x is equal to natural log of 72. Or if you do that in your calculator, natural log of 72 is 4.27667, so on and so forth. Okay? And so you can see how you can check your answer. You can do e to that answer, and you'll get 72. So on this next one, first we have to divide by 3. Okay, we're going to do our algebra the same way. So we have 2 to the x power equals 42 divided by 3, which is 14. Now, what are we going to do to get this 2 to the x power out? We have to do log base 2 of both sides. Log base 2 on both sides. That log base 2 cancels that 2 out. We're left with x. X equals log base 2 of 14. Log base 2 of 14 ends up being, if you do that little math in your calculator, 3.80735. And I'm just going to check my answer. I'm going to do 3 times 2 to that answer, and I end up getting 42 when you check your answer there. So again, we're just doing algebra. We're just solving for x. So let's take a look at this. What's the first thing we're going to do? Another solving an exponential equation. What's the first thing we're going to do is we're going to add 3 to both sides. So we get 4e to the 2x is equal to 5. What's the next thing we're going to do? We have to divide by 4. We have to divide by 4. So now we have e to the 2x is equal to 5 fourths. Now, how do we move the e over to the other side? Because this 2x is grouped together. So we're going to have to do natural log to both sides. Natural log to both sides. So now we're left with 2x, because this natural log and e canceled out. 2x is equal to natural log of 5 fourths. Natural log of 5 fourths. Now what's the last thing we're going to do is we're going to divide by 2. So x is equal to 1/2 of natural log of 5 fourths. Okay, so 0.5 times natural log of 5 fourths, and if you do that in your calculator, you end up getting 0.11157, and so on and so forth. Okay, now there is something interesting here. Something very, very, very interesting is remember, this 1/2 is in front of the natural log. So you could also call this, using our properties of logarithms, natural log of the square root of 5 fourths, because that's to the 1/2 power, or natural log of the square root of 5 over 2. Okay, and if you do that in your calculator, you'll still get 0.11157, so on and so forth. Okay, so that is solving an exponential equation using algebra. Here's solving a little bit more of a complex equation. You can still do it, you just do step by step. So we're going to add 4 to both sides. So now we're left with 15 equals 2 times 3 to 2x minus 5. Okay, what's the next step? We're going to divide by 2. Divide by 2. So now we have 3 to the 2x minus 5 equals 15 halves. What's our next step algebraically is we have to get this 3 to the out. And how do we do that? We do log base 3 on both sides. Log base 3. So what are we left with now? This log base 3 of 3 canceled out. So we have 2x minus 5 equals log base 3 of 15 halves. Log base 3 of 15 halves. So now we're going to add 5 to both sides. Add 5 to both sides. So again, I'm just taking it step by step. 2x equals log base 3 of 15 halves plus 5. And last thing I'm going to do is divide everything by 2. So divide all of that stuff. Log base 3 of 15 halves plus 5. We're dividing that by 2. So that was example 3, which is solving an exponential equation. Solving an exponential equation. And you can see how it does kind of, it gets a little bit complex at times, but we're just going step by step by step by step. And you can obviously get an approximate number for what x will be in your calculator and check your answer there. Okay. What happens if we have an exponential in quadratic form? So if you take a look at this equation, we have e to the 2x minus 3e to the x plus 2. Now, think of this in a different way. Think of this as x squared minus 3x plus 2 is equal to 0. You could easily factor that guy, can't you? Because we have x and x is x squared. We're going to do plus 3 minus 1, minus 2 minus 1, minus 2 minus 1, which minus 2 times minus 1 equals positive 2. That adds up to negative 3. Okay, this is the exact same thing that we have here when we do this little factoring job here. So we have e to the x times e to the x equals e to the 2x, which is what, just like you had here, x times x is x squared. Okay, it's e to the x squared. And you have minus 2 and minus 1. Okay, that's awesome. It's the exact same thing as doing it via factoring. Okay, except instead of x's, we're using e to the x's. That's it. So now that means I have e to the x minus 2 equals 0. That could be a factor. Or e to the x minus 1 equals 0. That could be a factor. Which means e to the x is equal to 2, or e to the x is equal to 1. What's the algebra of e? Is natural log. So we could say x could be natural log of 2, or x could be natural log of 1. Okay, either one. So natural log of 2 is 0.693. All my chemistry students know that number. And natural log of 1 obviously is 0. Okay, now what you want to do is you want to check these numbers back in your original equation. And so we're going to check them back in the original equation, and both of them do work, so both of them are legitimate answers right there. Okay. Example 5. Solving logarithmic equations. What's the opposite of natural log? Is e to the, so we have 3x is e to the second power. Then we're going to divide by 3. X is equal to e squared divided by 3. Okay. On this one, you have log base 3 of 5x minus 1 equals log base 3 of x plus 7. You're going to do 3 to the and 3 to the. What does that do? That cancels both of these things out, which means 5x minus 1 equals x plus 7. We can get our x's to one side. 4x, we can get our numbers over the other side. 8, which means x is equal to 2 for this problem. Okay. This one here, let's divide by 9. So when we divide by 9, we have log base 2 of 3x is equal to 27 divided by 9, which is 3 right there. What's the opposite of log base 2? Is 2 to the. And so now we're left with our 3x is equal to 2 to the third power. 2 to the third power is equal to 8, which means x is equal to 8 thirds right there. And you can double check that answer in there. And here are our 3 examples of solving logarithmic equations. Here we're going to do another solving of a logarithmic equation. We're doing a lot of examples today. So we have minus 5 minus 5. We got 2 natural log of x is equal to negative 1. We're going to divide by 2. Natural log of x equals negative 1/2. What's the opposite of natural log? Is e to the. So e to the negative 1/2 right there. Or you could say 1 over the square root of e to the first power. Okay, which is the same. Here we're going to first divide by 2. So we have log base 5 of 3x is equal to 2. How do we do the log base? What's the algebra of log base 5? Is 5 to the. And so we're left with 3x is equal to 5 to the second power, or 25. We're going to divide by 3, so x is equal to 25 thirds, and that is your answer. Okay. One last example is checking for extraneous solutions. So here we go. Let's take a look at this one. So here we have natural log of x minus 2 plus natural log of 2x minus 3 equals 2 natural log of x. On this left side, we have to condense this. We can't do e to everything because there's an addition sign in between. Okay, and so we have to condense this together. So we have natural log of x minus 2, and what is adding? Adding is the same as multiplying. 2x minus 3. Okay, equals 2 natural log of x, or you could call that natural log of x squared when you condense it together. Now you can do e to the both sides because you've condensed it as well as you have had. And so that cancels him out. And now we're left with x minus 2 times 2x minus 3 equals x squared. And we're going to do a little bit of foiling here. So we have x times 2x, that's 2x squared. We have minus 3x, the inside guy, minus 4x plus 6 is equal to x squared. We can subtract this x squared on this side. So we're left with x squared minus, minus 7x plus 6 is equal to 0. And now we're going to do a little bit of factoring again. So what equals x squared is x sub x. What equals 6 is negative 6, negative 1, which means what are our factors is x can equal 6 or x can equal 1. So those are possible solutions, Now we can put them into our equation and see if it works. So you put in 6, so you have natural log of 4 plus natural log of 12 minus 3, that's 9, equals 2 natural log of 6, and you would see that works. But when you put a 1 in, you're going to get natural log of negative 1. And try natural log of negative 1. You get an unreal answer, which means that is an extraneous solution that does not work. You only have one solution, which is x is equal to 6. And so one last example. I tricked you. One last example. It's an application. You're going to invest $500. That's going to be your principal. So you have $500. And your interest rate is 6.75%, so 0.0675. And we want to know the time it takes to double your money, which means your money is going to be $1,000 because we're doubling that bad boy. So we're going to divide by 500. We're going to get 2 is equal to E is equal to 0.0675 t. And we're going to do, how do we get the E out of there? Is natural log. Natural log of 2 equals 0.0675 t. We're going to divide by 0.0675, so time is equal to natural log of 2 over 0.0675. If you do that on your calculator, I'm going to do that right now. Natural log of 2 divided by 0.0675, and we end up getting 10.2 years, 10.27 years there. And that's how much money it would take to double our investment. So that was a solving exponential and logarithmic functions. Boy, that was fun. I'll see you later, guys. Bye.